Today, we're diving deep into the turbulent world of Venus. Buckle up for exploring the extraordinary features that set this planet apart in our cosmic neighborhood. Get ready to uncover everything you've ever wanted to know about Venus. I'm Mike Adams, and welcome to All Things Space. At first glance, Venus is a stunning celestial body exuding a sense of calm and tranquility. However, don't be fooled by its seemingly serene exterior. Venture beneath the cloud layer, and you'll encounter scorching temperatures, volcanic activity, and an atmosphere that exerts an overwhelming pressure on its surface. Now let's zoom out and place Venus within the context of our solar system. As the second planet from the Sun, Venus stands as our closest cosmic companion. Its orbit, maintaining remarkable regularity, brings it to an average distance of 0.72 astronomical units, roughly 108 million kilometers from the Sun. But what sets Venus apart is its proximity. It boasts the least eccentric orbit, gracefully circling in almost a perfect circle. When Venus swings closest to Earth, a mere 41 million kilometers away, it becomes the brightest object in our night sky after the Moon. Despite its brilliance, Venus often plays tricks on unsuspecting observers, earning it a reputation as a frequent misidentification for UFOs, as even President Jimmy Carter once reported in 1969. Venus, our closest planetary neighbor, has a rich history that hints at a more vibrant past. Despite its forbidding appearance today, scientists are delving into innovative strategies to explore its harsh landscapes. Scientific observations of Venus date back to Galileo Galilei in 1610, noting its crescent phases. Subsequent missions, like Mariner 2 in 1962, revealed Venus's scorching surface temperature and slow backward rotation. Exploration continued with Venera 7 in 1970, achieving the first successful landing and data transmission from Venus's surface, and the Magellan mission in 1990, mapping over 97% of its landforms. Once a potential twin to Earth, Venus took a different evolutionary path, losing its water and succumbing to a runaway greenhouse effect. Its lack of plate tectonics, crucial for regulating Earth's climate, and a thick atmosphere without a robust magnetic field contribute to its extreme conditions. The absence of plate tectonics on Venus hinders the recycling of carbon dioxide, leading to a buildup of greenhouse gases and perpetually hot, dry conditions. The planet's volcanic activity documented by various missions, Venus now serves as a cautionary tale of planetary evolution. Ongoing exploration of Venus provides valuable insights into Earth's processes and the factors contributing to the diversity of celestial bodies in our solar system itself. Venus's surface exhibits volcanic forms, canyons, valleys, and liquid lava-carved channels, challenging its forbidding reputation. Recent studies suggest that Venus might have had a more Earth-like environment billions of years ago, potentially supporting life. Two volcanoes that constructed the Big Island are collectively about 150 kilometers across, but some of the coronae on Venus have grown significantly larger, with one notable feature spanning 2,600 kilometers across. The visible record of volcanic activity on Venus's surface sheds light on how the planet attempted to cool off approximately 500 million to a billion years ago. Around 500 million years ago, Venus experienced a massive eruption of volcanoes across its entire Earth-sized surface. The exact mechanisms behind this phenomenon and Venus's peculiar conditions remain subjects of ongoing exploration. Despite its diminishing water and challenging conditions, Venus, with its abundance of volcanoes emitting CO2 into the atmosphere, has condemned its surface to a climatic demise. Once a potential twin of Earth, Venus is a stark example of planetary evolution and the delicate equilibrium necessary for life to flourish on Earth. While Venus's surface remains inhospitable, its atmosphere presents unique opportunities for exploration. The High-Altitude Venus operational concept, HAVOC, proposes a mission with an entry vehicle penetrating the outer layers of Venus's atmosphere, deploying an inflating envelope, a 130-meter-long airship serving as a science city situated in the clouds of Venus. The HAVOC concept capitalizes on the distinctive characteristics of Venus's atmosphere. At an altitude of 50 kilometers, the pressure drops to that of sea level on Earth, and the temperature becomes comparable to a day in June in Europe, or the U.S. balloon-borne habitats could perpetually float in this upper atmosphere, serving as a base for scientific research. Envision a crew of scientist astronauts navigating an airship through the sulfuric acid clouds, propelled by electric motors powered by the sun. These floating platforms could explore Venus's surface, investigating its deep history, the connection between land and atmosphere, and searching for signs of live volcanoes. Soviet researchers demonstrated balloon science with the 1985 Vega 2 probe, utilizing turbulent thermal currents to navigate Venus's atmosphere. Descendants of such balloons may deploy from airships to form a global sensor network, triangulating their positions and detecting signs of seismic activity. Venus's atmosphere harbors complex stories that scientists are eager to decipher. Molecular fossils in Venus's atmosphere, such as noble gases, could provide clues about its original atmosphere and whether it once had lakes and rivers on its surface. The prospect of life in Venus's atmosphere is a tantalizing mystery. Dark patches that absorb ultraviolet radiation might be indicative of life forms in the clouds. The harsh conditions, including strong acid in the clouds, are obstacles, but extreme offals on Earth suggest that life could adapt. The idea of life developing and migrating upward in the clouds as the surface became inhospitable adds an intriguing layer to the search for extraterrestrial life. While the cloud tops of Venus may offer temperate conditions, its surface remains unforgivingly hot. Engineers exploring Venus must take a meticulous mechanical approach, considering the extreme conditions that electronics and mechanisms must endure. Exploring the surface of Venus requires mobility, but conventional strategies don't apply. Wind energy becomes a potential source, with wind turbines harnessing low-speed, high-density winds for mobility. Venus poses intriguing questions about planetary evolution within the habitable zone of our solar system. Understanding different aspects of Venus's history could redefine the habitable zone and encourage the exploration of seemingly inhospitable planets. As astronomers look beyond our solar system, Venus offers a unique opportunity to study an alien planet up close. The divergent paths of Earth and Venus encourage scientists to explore seemingly inhospitable planets, potentially expanding the search for life in the galaxy. Two planets, born together, initially harboring oceans and atmospheres rich in water vapor, have taken divergent paths in their evolution. While one became adorned in the greens and blues of life, the other became cloaked in a toxic haze with a surface dominated by volcanic activity. The question of which type of world is more prevalent in the cosmos remains open. Now, let's talk about Venus's peculiar dance with the sun. While it does experience transits crossing in front of the sun from our viewpoint, in pairs with an 8-year gap, occurring once every century. If you missed the last one in 2012, you'll have to wait until 21 and 17 for the next celestial spectacle. Venus, a planetary rebel, challenges the solar system norm by rotating clockwise, unlike its counterclockwise orbiting companions. With an unhurried rotation taking a leisurely 243 Earth days, Venus stands as the second most spherical object after the Sun. The mysteries of its backward rotation might be attributed to a colossal ancient impact, tidal locking, or effects on its atmosphere. Often dubbed our sister or twin planet due to similar mass and size, Venus deviates when it comes to atmospheric conditions. With a diameter slightly smaller than Earth's and a density of 5.3 grams per cubic centimeter, Venus exhibits a gravity only a tenth weaker than Earth's. However, the stark contrast lies in its atmosphere, which boasts a pressure 92 times greater than Earth's, creating a stifling environment akin to being a kilometer underwater. The atmosphere, composed mainly of CO2 and sulfur dioxide clouds, contributes to Venus holding the title for the strongest greenhouse effect in the solar system. Surface temperatures soar to an average of 462 degrees Celsius, surpassing even Mercury's, despite receiving only 25% of the solar radiation. Moving at a leisurely pace, Venus' slow rotation translates to an interesting fact. A Venusian year lasts 224 Earth days, surpassing its day, which clocks in at 243 Earth days. Its axial tilt of only 3 degrees and lack of significant seasonal changes paint a picture of a planet that doesn't rush its celestial routine. Descending through the thick atmosphere, where winds at the surface move at a modest 6.5 kilometers per hour, the atmosphere's density creates a force capable of shifting small rocks and dust across the surface. However, ascend to the cloud layer and wind speeds hit a brisk 300 kilometers per hour, circling the planet every 4 to 5 Earth days. Venus's atmosphere, shrouded in sulfuric acid clouds, is not just a visual spectacle. It reflects about 10% of sunlight, concealing the planet's surface and giving rise to occasional lightning storms. Beneath this cloud cover lies an intricate landscape discovered through the pioneering efforts of Russian probes like Venera 7, the first to land on another planet and send data back. Radar-equipped probes have since unveiled Venus's surface, unveiling a mosaic of cooled lava plains and over 167 volcanoes larger than 100 kilometers in diameter. While Earth's volcanic activity is more regular due to plate tectonics, Venus, with an estimated crust age of 300 to 600 million years, underwent a resurfacing event covering 80% of its surface with lava plains. As we bid farewell to Venus, with its tumultuous atmosphere and mesmerizing features, we express our gratitude for joining us on this cosmic journey. If liked this video, click the like button, subscribe to this channel, click the bell so you can get notified when we release new content. Until next time, keep your eyes on the skies and we will see you in the next video.